Hello everyone, myself Dr. Sunny Kumar. I am assistant professor in Department of Chemical Engineering, PKG College of Engineering Panipat and Technology Panipat. This is my lecture 7 of unit process subject. Okay, so in the previous lecture we have discussed about what are the different factors controlling the alkylations. Okay, and we have discussed the equipment for alkylation is also important, and the materials of construction, it is also matter, the corrosion of apparatus, types of equipments, which type of instrument we are used, this is also very important parameter, and the recovery of alkylatic products, this is also a very important parameter for which controls the alkylations. And the last one is safety. What safety is also very important parameter for this alkylation reaction. Okay, so if you will see this image, this shows how the corrosion can happen in a plant. Generally the pipes, if you are using any acidic or basic system, so they generally oxidize the these surfaces, and then they can corrode, and the fouling can happen and corrosion can happen on the surface, and that corrosion and fouling can interfere our reaction, so that affects the product, whatever the product we are getting, that the production yield and the quality of the product can decrease by this. So these parameters are very important. And the catalyst we are using, suppose you are using the HF or H2SO4 or any other catalyst, that is dependent upon what type of product you are using. So during that catalyst, what is the nature of the catalyst? It is in acidic medium, acidic catalyst, or any other catalyst. So that catalyst also affects by using that catalyst, we have to choose a specific type of equipment. So this is very important parameter which we have to consider. And if you will see, this is a before bursting. If the pressure is high, so they can easily burst. This is after burst, and it is a before burst. So this can happens during the valves and the safety valve. This is a safety valve, they can break if inside operating pressure will be high, so that they can easily break. And this can happen due to the corrosion, because the strength of the material can decrease when it is in corrosion form. So this is the previous lecture we have discussed, and we have also know that we use for the equipment the steel, and but steel is not enough, so we have to coat it one another layer, which is called lining, generally called lining. So monal lining or enamel lining. Monal is based of 2-3 materials, the nickel and iron. So these are the 2-3 materials generally we use for cobalt, I think. So these 2-3 materials generally we use for the monal, and for this enamel lining we have used the glass steel. So this type of lining we do for the protect from the corrosion. So this is the something we have read, and how where we generally use these equipments. Generally this alkylation reaction used in petroleum industry. This is a very common example for this alkylation reaction. So these are the things we have used, and in during between we have for the separating of the different solvents we generally use for the distillation. This is also a important part during this reaction. So these are the things we have discussed in in the previous lecture. So in the today lecture we will discuss about the first one is effect of alkylation. What is the effect of alkylation and the technical alkylations, and in the technical alkylation we will discuss about alkyl aryl detergents, alkylate for the petroleum industries, and thermal alkylation, and the hydrogen fluoride alkylation. So these things we will discuss today, and we will tell you that how we can produce the alkyl aryl detergents, and how they are different from the petroleum based detergents. So these things we will discuss, and we will make a flow sheets of this, how we can produce and what are the equipments required for the producing of this type of detergents, and for the petroleum industry how we can use this alkylates. We will also do some study for this, and the thermal alkylation, why where this thermal alkylation is required, and the HF alkylation. So these are the four, but there are remaining some technical alkylation which we will discuss in the next class, but today we will discuss these topics. Okay, now we will start our topic. So the first we will discuss what will the effect of alkylation. So although the effect of alkylation on the properties of organic compounds is contradictory, there are some general observations that are of value, particularly in the field of motor, fuels, medicines, dyes, and solvents. So the effect of alcohol, so this organic compound generally we do use for this, and the high octane number octane motor fuel are manufactured in large amount by alkylation because the desired branch chains are economically obtained. And the Schimberg formulated a series of rules regarding the effect of alkylated group on psychological activity, which may be summarized as follows. So in the first place, a close connection exists between medical action and the ordinary physical properties of volatility and the solubility. So these are the two properties generally we consider for during the reaction. And in the aliphatic paraffin series, the lower member, which are more volatile, exhibit a narcotic effects that is absent in the insoluble and non-volatile higher member. So this thing we have to consider during the this, if these are the effects of the alkylations, and this is formulated by Schimberg. So this is the scientist name. So the alkylation often causes very poisonous compounds to lose this effect. Examples: nitriles and isonitriles, which are RN, and this is triple bond, not two bond, it is a triple bond. So we have to consider this one. Okay, the action of alkyl radicals can be masked or inhibited by the presence of other radicals. So this is illustrated by the behavior of methyl, dimethyl, and trimethyl amine, which reacts like ammonia but have no narcotic effects. Okay, so in this conduct, these amines follows Schimberg's preceding rules, and are less toxic than ammonia. So this is the selection of solvents which very important, which type of solvents you are using. So ammonia is very generally evaporate in very low temperature, and they can people can easily inhale, and that can affect our nerve system and our lungs also. So these things generally important. So the psychological action of alcohols and the ether is ascribes to the nature of the alkyl groups. So this is also very important. So alcohols and ethers are alkyl groups, how they are attached, and this thing is also and what is the physical properties, the volatility and the solubility. These two things are very important. For the ether, the single or mixed, the effect is due to the presence of the alkyls, each of which acts independently of the others. Okay. So one of the most interesting studies of the effect of various alkyl groups on psychological activity is illustrated by the this alkyl derivatives of resorcinol, which are discussed under hexyl resorcinol. Okay, that will we will discuss later. Okay, so this is example of alkyl groups. Okay, the bactericidal action at first increase with the length of the side chain and then diminishes because of decreased solubility of the alkyl resorcinol. So this is also important, the solubility and previously the this volatility, these are the parameters, and so here it is a solubility decreases, and coincident with this increase is found decrease is found a decreases in toxicity, because solubility will be less, so that can less toxic. So the phenols was the first antiseptic used, and a truth study of its derivatives has been made. So in the medical section we are also use this thing, this alkylation reaction. So this phenols generally we use for the antiseptics. Okay, so this is this alkylation reaction is very important. These are the effects. So the parameters are the solubility and the volatility, and they can if the solubility will be less and if or high, and if the volatility will be less or high, that's very important for the safety purpose, and how they can affect to the human. So the substitution of a methyl group for the hydrogen in the ring of phenol forming the cresol increases the antiseptic action. In the case of the dihydroxybenzenes, the alkyl derivatives of resorcinol have been carefully investigated. So, and it is found that the entrance of the methyl group into the ring forming orcinol depresses the bactericidal power. So the influence of higher alkyl groups on the nucleus of the resorcinols molecules is considered under hexyl resorcinol. Okay. So that is the we have discussed the effect of alkylation. Now we will discuss this technical alkylation. So in the technical alkylation, first we will discuss the alkyl aryl detergents, how we can produce and what will be the effects, and how the other detergents generally be prepared. This thing we will discuss in this technical alkylation. Okay. Alkyl aryl is used to designate the predominantly important class of aliphatic aromatics organic compounds which are sulfonated to manufacture detergents. Okay, so it is a aliphatic aromatic organic compounds and which are sulfonated to the manufacture of detergents. Benzenes is more almost always the aromatic compounds alkylated either with dodecene or with caryl chloride. The dodecene is normally a propane tetramer containing 12 carbon atoms and with a boiling range 350 to 420 Fahrenheit. With caryl chlorides, the benzene is alkylated with the 10 to 14 carbon kerosene but of relatively straight chain hydrocarbons after chlorination. So this is important. So the only the 10 to 14 carbon kerosene molecules cut off slightly straight chain hydrocarbons after chlorination. So they can be small molecules generally they generate. So both alkylations are catalyzed by aluminum chloride and hydrogen fluoride or sulfuric acid. So this is a flow diagram for alkyl aryl sulfonates. If you will see this diagram, so these are the different things. This is a dodecene and this is a storage collector. This is a storage collector. Okay, and this one is the benzene fractionator. This is a benzene fractionator, and this is a intermediate fractionator, and this is a dodecyl benzene fractionator. So and after that, after the this fractionator, the upper part goes to the vacuum and the lower part we collect the hydrocarbons, which is heavy alkyl aryl hydrocarbons, and from the top of this we directly send to the dodecyl benzene storage tank here, and this is a sulfonator, and where we treated with the sulfuric acid this dodecyl benzene storage, and this is a settler, spent acid settler. It is spent whatever the remaining sulfuric acid is there, so they can easily settle, and the spent acid we will remove from the bottom, and then it is going here this dodecyl benzene sulfonic acid. Now this molecule is changed to the sulfonic acid, and we will another neutralizer. This is a neutralizer, and we will neutralize by the sodium hydroxide. This is a in this section this is a sodium hydroxide we are using, and after that sodium dodecyl benzene sulfonate slurry we directly send to the this crutchers. So this is a builder. This is I think again is settler type. This is a builder we are introducing here, and from the bottom, after that we directly send to this spray dryer. This is a spray dryer. From the top we are spraying our this solution, which is sodium dodecel benzene sulfonate slurry. We directly send here, and by the sprinkling we spreading, and this is dry detergent to packing. This is we will get the dry detergent, because here the spray drying is happening. Our upper side is, this is a blower, and this is a moist air generally we will send. So this is a combustion gases, and whatever the some gases we give for the blowing. So this is a furnace, how we are producing this gases. This is a furnace, and this is here is combustion gas is producing, and we directly sending to the this is spray dryer, inside the spray dryer, and which is drying our detergents. Okay, and this is which is called sodium dodecyl benzene sulfonate slurry, and you will get it. So this type you can make this alkyl aryl sulfonates, so which is a you can say that dry detergent, and then you can directly send to the packing. Again I will explain you. So this is a initially you have to this two components, dodecene and the benzene. These are the your monomers in reactants, and this is a storage tank, and here is a catalyst, fresh catalyst you will send here. This is the fresh catalyst you will introduce. Okay, and this is a settler, the storage contractor, and this is a settler. After that you will send to the this fractionator, which is a benzene fractionator. In the crude you will directly send, and you will get the benzene from there. After that you will send in a again distillation column, which is the intermediate fractionator. From the light alkyl aryl hydrocarbons you will get it from the top, and the other you will vacuum it, intermediate fraction you will remove, and then again you will send to the another distillation column, which is a dodecyl benzene fractionator column. We will say if first one is the benzene fractionator column, the second one is the intermediate fractionator column, and the third one is dodecyl benzene fractionator column. And in this column, this is a distillation column. Okay, so the upper part we will do the vacuum, and the lower part we will get the heavy alkyl aryl hydrocarbons. That is not our we are not using this one. We are whatever the in upper part, which is the dodecyl benzene. So we will collecting from the top side, and this is a condenser. After condensing we will collect it, and then we are sending to the again we are sending to the this storage tank. This is a storage tank for the dodecyl benzene storage, and then we will treat it with the sulfuric acid in sulfonator. So this is a sulfonator chamber where we will treat this dodecyl benzene here, and then again we will sulfuric acid in the water, because it is a exothermic reaction generally happens. So this is required, the water is required, and we will send to the settler, where spent acid we will settle down and remove this dodecyl benzene sulfonic acid. Now the sulfonic group also attached to this benzene decyl benzene. So now we will send to the neutralizer. We will neutralize with the sodium hydroxide. Initially the acidic, now we will some base we will add, otherwise it is will highly acidic in nature, this our this detergent. So we will neutralize with NaOH and sodium dodecyl benzene sulfonate slurry, we will get it, and then we will send to the this crusher. So here we will build this thing, and we will whatever the remaining part we will settle down, and then we will directly send to the this sprayer dryer. In the spray dryer, by the use of the combustion gases and the blower, we will dry our this sodium dodacyl benzene sulfonate slurry, and which collecting from the bottom, which is dry detergent and for the packing. So this is a simple process. So we have used two this component reactant, which are dodasine and the benzene, and we directly sending to the and the crude oil we are sending to the this fractionator, the distillation fractionator. These are our crude oil is our main component. We directly send to the distillation column, and then after benzene's fractionator, again from the bottom we send to the intermediate fractionator, where we will collect light alkyl aryl hydrocarbons. We will not use, but for the bottom we directly send to the dodacyl benzene fractionator column. Here for the heavy part from the bottom we are not collecting, for the upper part we will collecting, and then we directly send to our storage tank. Okay, in the where we will have this dodasine benzene storage, and then we directly send to the sulfonator and treat it with the sulfuric acid and the neutilizer, where with this acidic nature we will change to the normal pH. So it will be NaOH treatment is required. Then we will send to the sprayer dryer, and when dry our sodium dodecyl benzene sulfonate slurry, and then we will get the dry detergent. So this is a very simple flow diagram for the alkyl aryl sulfonates, which is very important for your for producing the detergents. It is very important. You can also open your industry by using this. Okay, so this is a simple reaction. What is the reaction occurring in this flow sheet? So you will see here. So this is a benzene and a dodasine, which is a propylene tetramer, and if you are using the aluminum chloride at 115 degrees centigrade, so dodacyl benzene will produce. So this aluminum chloride is your catalyst. So this is a simple reaction, benzene and dodasine. These are the two components when they will react in the presence of aluminum chloride and the catalyst. So you will get it this dodacyl benzene. So the figure, the flow sheet shows represents the continuous flow diagram for manufacturing of alkyl aryl detergent. Okay, and the benzene is alkylated with dodasine catalyst by aluminum chloride continuously introduced. Okay, actually this aluminum, because it is a catalyst, so they increasing the rate of our reaction. So the temperature is kept at 150 degree Fahrenheit as a maximum. This is being controlled by cooling coils or by circulating a part of benzene alkylate through an external cooler and back to the agitated alkylator. So the alkylator is followed by a continuous settler. So we have seen this temperature is kept 115 degree and cooling coil will be used, and we circulating passes benzene alkylate through the external coil and back to the agitated alkylator. Alkylator is a continuous settler. The benzene is in axis to suppress the formation of isomer, so which is a heavy alkyl aryl hydrocarbon. And after separation of aluminum chloride sludge, the charges goes to the benzene fractionator, where the excess benzene is distilled overhead and recycled again. So this is, I think, again we will recycle the benzene. So the from the bottom the benzene fractionator, as shown in figure 14.4, for the bottom we directly send to the another intermediate fractionator, the furnishing as overhead a small quantity of light alkyl aryl hydrocarbons, and then to the dodacyl benzene vacuum fractionator. Okay, for the overhead we will not do. For the bottom we will make it, and then we will directly send to the next vacuum fractionator. So the dodacyl benzene has a boiling range 530 to 600 degree Fahrenheit, and is blend predominantly of monoalkyl benzene with a saturated side chain averaging 12 carbons. Okay, and the solubility of the sodium alkyl benzene sulfonate were found to decrease considerably with the length of alkyl group. So the surface tension shows a minimum value of the dodecyl group, and the naphthalene and the phenol and its homologies are also alkylated to produce synthetic detergent which have excellent properties but are more expensive than the detergent produced from the benzene. So this benzene based detergent is very less costly, but we can also produce from the naphthalene and the phenols. From the phenols, these are the can also be the reactants we can use for the producing of the this detergents. Okay, so now we will read about again the alkylate for the petroleum industries. So the manufacture of the so-called alkylates has furnished an important constituent of high quality motors and aviation fuel. For the this transportation we have required high quality motor and aviation fuel are required. This is made by the reaction of olefins and paraffins or isoparaffins and has been carried out commercially in several ways. The first one is by thermal alkylation in the vapor phase, and second one is by catalytic alkylation with hydrogen fluoride and sulfuric acid or aluminum chloride hydrocarbon complexes, all in the liquid phases. In both of these methods, it is necessary to keep the olefin in a low concentration, which suppresses the tendency of these hydrocarbons to polymerize, and the paraffins in a high concentration to favor the paraffin olefin junctions. So about 3 to 8 moles of the isoparaffin is required for 1 mole of the olefins or olefins, and the excess isoparaffin is separated from the alkylation product and recycled. So in 1956 it was reported by S.R. Stiles that there are 60 alkylation plants in the US, including those under construction, ranging in the size from 650 billion per day to 12,500 BBL per day, and having a total capacity of more than 2,58,000 BBL per day. Of these, 19 are HF alkylation plant rated at 54,000 BBL per day. So the sulfuric acid units accounts for the other 47 with capacity of 2,03,000 BBL per day. So so today we have discussed about um, the effect of alkylation and the technical alkylation, alkyl aryl detergent, how we can produce the detergents, and alkylate for the petroleum industries, and this thermal alkylation and HF alkylation we will read tomorrow in the next lecture. Okay, but if you will summarize all this today lecture, so this detergent manufacturing is very important. We have seen this one. So what are the parameters which are affecting our this alkylations? So generally we have read about the properties, so which are volatility properties, which are solubility and volatility is very important for the medical purpose. If you will you have less solubility, they can easily go through your nose and they can easily soluble, and your nerve system can damage or lungs can damage. And the volatility and the solubility will also, if the solubility will be more in your in the water, so they can easily dissolve in your blood also, so they can also affect over the system. So these things are very important. The solubility and the volatility of your solvents are very important for this alkylation, as we have seen for this. And in between we are some very poisonous compounds we generated, which are this isonitriles. This is which is this one, this isonitrile. Okay, and other various type of alkyl groups, which is hexyl resorcinol, which is this one you will see here. And under antiseptic actions we can also do by the ring of phenols, which is cresol can increase this forming, methyl group forming. So this resorcinols is very carefully investigated we have did. And another, what are the different technical alkylation we have discussed. We have produced this alkyl aryl detergents, and generally the components, the reactants are the benzene and dodecene, and we are using aluminum chloride as a catalyst. And this is our flow sheets which are using for the producing of detergent. So in this we are using the three type of distillation column, the benzene fractionator or the intermediate fractionator, or dodecyl benzene fractionator, or you can also the vacuum fractionator you can also say, and then after we will treat it with the sulfuric acid and this in sulfonator and the sodium hydroxide for neutralization, and then we will directly send to the this spray dryer, where we will dry our chemical and produce this detergent, and then we will directly send to the packing. So this thing we have discussed in today lecture. So this is very important detergent, but we have also seen instead of this producing this benzene, this detergent, we can also produce this detergent by the naphthalene and the phenol, but they are very expensive. So we generally use for the benzene and dodecene for producing our detergent. So this is a important thing. And we have also seen how we can use this alkylated reaction in petroleum industries, and these alkylation reaction used for the aviation fuels and the motor fuels for manufacturing. And what are the generally there are the two ways for producing the thermal alkylation of the in the vapor phase, and by the catalytic alkylation with the hydrogen fluoride or sulfuric acid or aluminum chloride hydrocarbon complex, and in which are in the liquid phase, which we have seen here also in the previous detergent manufacturing. Okay, but in the both cases the olefins in the low concentration we suppress the tendency of the hydrocarbons. So this thing we have read today. So in the next lecture we will read about some the remaining technical alkylation parts, which are thermal alkylation and hydrogen fluoride alkylation and the sulfuric alkylation. So this thing we will read in the next lecture. So thank you very much. If you have any doubt related to the today lecture or the previous lecture also, you can directly mail me. This is my email ID, chemicalsuniraj@gmail.com, and this is my website. This is my Google website. So you can also if you require some other topics, you can also read here in my website. So thank you very much for listening.